Hello, this is AP Calculus BC class with Mrs. Ryu. Today we are going to talk about chapter 9.1. It's called alternating series. Let's get started. So what is alternating series test? It's when you have a positive AN, okay? AN is all positive, okay? Then you have a sigma -1 to the nth power, or -1 to the n plus 1 power. So that means you have a positive, negative repeating. Okay, so that's what we call the alternating series. All right, it converges. It converges when it satisfies two conditions. Okay, very important. Number one is when the limit value equals 0. Okay. Number two is when an plus 1 is less than or equal to an. Okay, and let's prove this. Let's say that I have a sigma 2n. Okay, so I have an even number of terms. So that's a1 minus a2, a3 minus a4, right? Because positive, negative, repeating. Okay, I can rewrite this to S2n. So I have a1 minus a2 minus a3, a4 minus a5. Okay, and one thing that we know is this, right? An plus 1 is less than or equal to an, right? So that means a3 is always less than or equal to a2. A4, a5, let's say a5 is less than or equal to a4, right? That means a2 minus a3 is positive or negative? It's always positive, right? a4 minus a5 is also positive, okay? So pretty much what I'm doing here is subtracting from a1, I'm subtracting something positive. I keep subtracting something positive. That's what I'm doing here, okay? So which implies it says S2n is less than A1 because I have A1 and I keep subtracting something positive. So S2n must be less than or equal to A1, right? That means S2n is bounded, so it converges some value L. Okay. All right, and I'm gonna change the color to red, and I see that starting the A1 to this point here, A2n minus 1 is this red part is what? S2n minus 1, right? So I have S2n minus 1 minus A2n equals S2n. Okay, so I have, let's add limits here. Limit S2n equals limit S2n plus limit A2n. And we know that this value here converges to L. And we know that the limit A2n converges to 0. So limit S2n minus 1 also converges to L. Okay, that means here's the conclusion. Because S2n converges to L, S2n minus 1 converges to L, that means Sn converges to L, right? So when you have an alternating series, positive, negative, repeating, when it satisfies these two conditions, it converges, okay? All right, next slide. Example number 1, okay? It says determine the convergence or divergence of the series. Okay, so I have -1 and +1 power. So that decides the sign repeating, right? Positive, negative. And 1 over n is, this is what is my AN, right? So pretty much this series goes let's say n is 1, then I have -1 plus 1/2 minus 1/3 plus 1/4. Okay, is it gonna converge or diverge? So you check two things. Number one, when you have a limit an, so I have a limit 1/n as n approaches infinity. Is it 0? And the answer is yes. Okay. Number two is 1/n plus 1, 1/n. Is it less than or equal? Okay, and yes. Because it satisfies two conditions, this series converges. That's the answer. Okay. All right, next slide. All right, example number 2. Using the alternating series test, we are going to determine the convergence or divergence. Okay. So how are we going to solve this problem? Is I'm going to split. Okay, and I'm gonna make some changes here. So I have sigma n over -1 to the n minus 1 power, 2 to the n minus 1 power. Okay, I can split like this, and I can rewrite this to -1 to the n minus 1 power, the front, and I have n over 2 to the n minus 1. Okay, all right, so the first part here decides the sign. Okay, so positive, negative, positive, negative, positive, negative. And the second part is what? My an. So to determine whether it converges or diverges, we need to check two things. Okay, all right, so number one, as n approaches infinity, n over 2 to the n minus 1 power, is it 0? That's the question. And the answer is yes, because what? Because if you apply the L'Hopital's rule, then I get a limit 1 over ln 2 2 to the n minus 1, right? You differentiate the top and the bottom. So that's 0. So yes, it satisfies the first condition. Number two is what? The n plus 1 over 2 to the n. So this is a n plus 1. Okay. Is it less than or equal to n over 2 to the n minus 1 power? Okay. So I'm gonna rewrite this. Is it okay? I'm gonna rewrite this to n plus 1 over 2 to the nth power, less than or equal to, is it less than or equal to n over 2 to the nth power 1 over 2. Okay, and then I can remove 1 over 2 in the bottom and put 2 in the top, right? Okay, so because I have 2 to the n power, 2 to the n power, both in the denominator, I can get rid of it. So all I'm gonna compare is n plus 1 is less than or equal to 2n. And if you move n to the right-hand side, then it says as long as n is greater than or equal to 1, yes. Okay, so it satisfies two conditions. So my series here converges. Okay? Okay, example number 3, let's look at A. It says alternating series is sigma -1 to the n plus 1 power, n plus 1 over n. So what is my an? What's my an? Is n plus 1 over n, right? So that's, if I have a limit an, is it 0? No, that's 1. Okay, so that's not 0. So it does not satisfy the first condition. So we can't apply the alternating series test. We can't apply, okay? We can't make any conclusion with this test, all right? Let's look at B. It seems like it satisfies the first condition, but I noticed that 1/2, and if we compare 1/2 and the 2/3, is the which one is it? 1, 2, 3, 4, 5. So A5 and here's A4. Is it A5 less than or equal to A4? No. Okay, so it does not satisfy the first condition, the second condition. So we can't apply the alternating series test. Okay, this series actually diverges because if you look at two terms each, okay, then what I get is, here is, I have 1, I have 1/2, I have 1/3, I have 1/4, so that's harmonic series, right? So that diverges, okay? Look at two terms each, okay? Then what I get is, here is, I have 1, I have 1/2, I have 1/3, I have 1/4, so that's harmonic series, right? So that diverges, okay? Here's the Bible verse of the day. Do not deceive yourselves. If any of you think you are wise by the standards of this age, you should become fools so that you may become wise. 1 Corinthians chapter 3, verse 18. Have a great day. I know there is pain, life ain't so easy. People go and leave you all alone. And I can't complain, I've been blessed with many things.